Hello everyone. I'm Nir from Red Hat, principal engineer Red Hat, working on Overt.
Hi, I'm Daniel Erez, an engineer at Red Hat and the contributor of Overt project.
So today we want to talk about running VM from thin air, from nothing, and the magic to do it. So first we introduce the problem with the disks, copying disk, and why we want to run VM without disks. And we see how we can cast the magic and how we can run VM without disks. And then we will try to hack Overt to add this feature. And finally, we'll see how we can actually do this using the changes we made, how we can expose disk, importing virtual machines quickly, and how we can use all the new features using the SDK. So first, Overt supports a lot of storage types. We support anything. In recent release, we support also Cinder storage. So everything is good, but how do you use a disk which is not in your Overt setup, right? You cannot access the iSCSI server or whatever storage. Maybe it's a local file on some real machine, and you have some nice VM there that you want to get. So what do you do? Well, it's not new. We have a lot of solutions for importing VMs. From LiveVirt, from VMware. We can download disks and upload them to Overt. But big disks are big, and copying them is slow. So do we have a better solution? For example, maybe you can use some magic to turn this frog into a princess. And we do. What you see here is a real QEMU command line running VM without any disk with NBD URL. So we know that QEMU is very complicated and the command line is very complicated, but this is a real command line that works. And QEMU supports a lot of external disk format, network disks like SSH and HTTP and FTP and many others. So I think it would be useful to use some disk on another system without copying it. Let's try to change Overt to do it. So now Daniel will explain how we can cast the magic.
Okay, let's see how can we cast the magic in Overt. So we have our little Overt mouse on the left side and the tasty cheese on the external system. How do we help our mouse getting the cheese? So first step, we have a tasty disk on some external system and it's connected to a VM, but we cannot access it. What can we do? First step, stop the VM. It will take just a few seconds. You can see the time elapsed on the upper left, upper right corner. So next, we need to expose the disk with QEMU NBD, the external system. Next, now we can create a temporary disk on Overt. Just make sure that the disk is in read-only mode, so we don't corrupt the data. And now this is about 15 seconds elapsed. Next step, we can simply start the VM with the temporary disk. So less than 20 seconds, we have a running VM on a disk that is on an external system. Okay, now we need to decide whether we want to delete or keep the VM. Do you want to keep or delete? By raise of hand. Someone? Good enough. Let's keep. Try to keep it. Okay, if we want to keep it, we just need to mirror the temporary disk to the destination. We do this by using live storage migration, which is a feature we already have. Next step, we simply pivot to the destination disk, and then the VM can use the new disk with minimal downtime, like 20 seconds. And next step, just for cleanup, delete the temporary disk in Ovid. Next, unexpose the external disk, since we exposed it earlier with QMNBD. Okay, let's see what we do if we want to delete it. First step, shut down the VM. Next, delete the temporary disk and unexpose the external disk. So this is the basic rollback and cleanup. Okay, so now Nir will show how to hack Ovid.
So how can we actually implement this in Ovid? Basically, you can do this flow without changing Ovid code. If you create a disk, go to the disk directly and rebase it on NBD URL. But we wanted something more easier to use. So we have to dirty our hands with Ovid code. So first we need to change the Ovid API model. Everything in Ovid is designed using the API model. So we have a disk object. We want to edit external disk property. So we can plug there one of the many URLs that QEMU supports. This was easy, changing one file. Then we need to work a little more on engine, adding external disk argument when you create a disk and pass it to VDSM. This is much more work. And you want Daniel on your side when you're doing it. And then Daniel added external disk URI in the UI, so we can just plug a URL in the UI when we want to create the disk. Again, more work. And finally, we need to change VDSM, which was probably the biggest change, to accept external disk, validate it, and do anything you need to use it. And of course, we want an example script in the SDK showing how you can use this API, which was the biggest part. And I didn't mention Ansible. We also have Ansible layer that we didn't touch. But probably Ansible we want to allow using it. And once you finish all the changes, you need to build Ovid. It's not so trivial. First, you need to build the Ovid engine API model, because engine depends on it, and Ovid engine depends on it, and the SDK depends on it. And once you build everything, you can build VDSM and try everything. Now let's move to Daniel to explain how do we expose this.
Okay, let's see how do we actually expose the disk with QMNBD. First, we need to create a test image. So what the cool kids are using today is Virt Builder. So just invoke the Virt Builder to create some Fedora 30 image. Next, expose the disk on external system. How do we do it? QMNBD is your best friend there. Simple command line. You can expose the image we created before. Now we need to test if we expose actually worked. We use QEMU image info on the NBD URL, and you can see that we have some info on the image, so the image was exposed correctly. Okay, let's see show demo, movie time. Okay, so this is a short demo just of the Virt Builder flow. Okay, so we invoke the command, uncompressing the disk, opening the new disk. And we can see that the image is created. Now we will expose it. It is exposed, a few seconds. Now we'll move to another machine and test it with QEMU image info. Okay, let's return. Okay, so now let's see how we can actually import the VM. So to create a VM, First step is opening the VM dialog in the UI, create the disk on some temporary storage domain, and specify the external disk URI in the disk dialog. Then just run the VM. Movie time again. I've created in the UI. Okay, so we click the new button, open the create VM dialog, specify some name, creating a disk, specify the size, then we'll specify the URL that we've just exposed of the external disk. In a few seconds we'll approve it, and with okay, the disk is created and done. Now we can run the VM and we see the boot in a few seconds with running VM with Fedora 13. And that's it for the demo. We have a sequel in a moment. Now, let's see how the VM XML really looks. We see the backing store. It uses source protocol NVD on some external system. So we know the disk is actually using the external system, the disk on the external system as a backing file. Now, how do we import the external disk? Again, we need to open the VM disk tab and push the move button on the disk to move it to the target storage domain, which invokes the live storage migration operation. Just another small demo. It's open. Okay, so we click on the VM as before, find the disk, find the move button, click on it, select the target domain, approve, and this will start the live migration operation. It could take a while, since it actually copies the entire data from the source to the target. So we can continue. Just a sec. Okay, so Nir will show you all about the SDK. Take it from here, Nir.
So using the UI is nice and easy, but if you want to write some interesting application, you want something that we can program. So let's see how we can use the SDK using external disks. First, we added external disk property to disk. So you can just create a disk with external disk. And of course, the person writing the application must handle the exposing of the disk, which can be NVD or HTTP or whatever. So we did not implement anything there. And then we need to create a VM and attach the disk to the VM. All this is standard overt API usage. And we have to start the VM. So the VM is running. Did we pull the rabbit from the hat that you've seen at the start? Well, not yet. We need to move the disk. So to move the disk to another storage domain, actually copying the data from the source into overt, we need to get the disk service using the disk ID and use the move command with the storage domain, destination storage domain. And then we have to wait a lot of time, of course, depending on the disk size and storage and bandwidth and whatever. But once all this is running, we can use the VM. Maybe our users are using the VM and everyone is happy. So let's see a demo of this. So we run the quick import example that you can find in the Python SDK after it will be merged. Everything here is not merged. We create the external disk using QEMU image. We created the new disk, created the VM, attached it, and the VM is powering up in 13 seconds. And now we can open the console and log in. Daniel did some cuts here, so we missed the boot messages. And we have a working VM that you can use. So if you want to keep this VM, the example script will just let you continue, and it will start a move operation. So let's answer yes. And now we can go and drink a few coffees, depending on the type of the disk, of course. In this case, it was pretty quick. It will soon be finished, but Danny made some cuts here again. So let's move to the next slide. How do we roll back? It's pretty easy. Everything is standard. Just stop the VM and remove it. That's all. You wait a little, and in a few seconds, you can remove the VM. So if you imported the VM and something is not right, so you have several seconds of downtime. Now you want to roll back. In a few seconds, you can roll back everything and start again the VM on the other system. And again, a demo of this. So again, we created a VM, but this time we said no. So we're just stopping the VM and removing the disk, which is pretty quick operation. And of course, you can have a VM with several disks, or it will do everything for you with the same API. So I think we pulled the rabbit from that. And another result of this work was a patent. We filed a patent for minimizing the downtime when importing virtual machines. So it will be available to anyone writing open source code and not to the people writing closed source code, which is nice. And if you want to learn more about this, you can check the patches which are in review. Actually, it's work from last year that we didn't have time to complete. All the demos are available in this URL in Google Drive. And if you want to know more about external disk, all the options that QEMU supports, you can use this section in QEMU manual. So that's all. Do you have any questions? Yes.
About the speed and how, like, the distance between the VM and the disk should be in general, or what's your experience with that?
The question is about, does it matter what is the distance between a disk and the VM? We didn't try it, but I believe with NBD it should be pretty efficient. So you probably can import VM from Amazon to your data center. I never tried it, right? We only tried on development setup on the same machine, running on VMs. But it should be pretty efficient. We tried with HTTP, it's less efficient when you have a lot of latency. But with a local HTTP server, it's also very fast. Yes?
NBD is unauthenticated, unencrypted. So, and you're not saying you have a separate storage network where it runs, but you're saying you have a client machine for somebody prepared a VM where it runs. So doesn't that kind of defeat the purpose of any security protocols that are in all of these virtualization solutions?
Well, you can use TLS. The question was if NBD is a security issue because it's not authenticated and not encrypted. So what we use here is indeed the unsecured NBD, but you can use TLS-based NBD. Recently, there was added a TLS PSK support. So you can pass a shared key to the server and to Ovirt. It's not implemented in Ovirt, of course, but we can implement it with secured NBD or HTTPS. Another question? Yes.
Is there any specific reason why you have exposed the image read-only, or is it just for the
So the question was if we need to expose the image read-only. Yes, if you have a running VM using this disk, you cannot use disk which some other VM is changing. It will corrupt the image on the other side. So it must be read-only. But you can, for example, create a snapshot on some other VM and expose the snapshot while the other VM is running. And then, of course, you will lose everything that was changed since the last snapshot. More questions? Okay, so thank you.